We think that the food that caused the problem is the last thing we ate. And this is not really the case, because there is hardly any disease, any foodborne illness that can show symptoms within 3 or 4 hours.
There are around 600 million people a year worldwide that are recorded to have a problem with food poisoning, and around 500,400 people die every year of food poisoning.
Exactly.
And 40% are less than 5 years old.
Very old techniques like adding salt and sugar. This is something that people should know, that when we add salt and sugar, most of the times it's not there to make it tastier, but it's there to make it safe.
You're saying that food could have been contaminated, but one person has an immune system and a gut bacteria that can deal with it, but the next person has a gut bacteria and an immune system that can't deal with it.
In all cases, we know that most of the people die actually from diseases and not from bullets and bombs.
Hello everyone, welcome back to the Eat, Burn, Sleep podcast. I have with me the amazing Associate Professor Andreas Karatsas. Is that how I say it?
Yes, exactly.
We've just been training, so I say it the Greek way.
Thank you.
And I haven't said it the French way. So Andreas is a microbiologist who works at the University of Reading. I went and visited Professor Glenn Gibson and all the microbiologists at the University of Reading recently, and I met Andreas, and I asked Andreas, what do you do? And Andreas told me what he does, so I thought I would have him on the podcast to discuss.
Thank you very much for inviting me.
Thank you so much for being here, because people like you are in labs all day. You're conducting research that takes weeks, months, years to have findings, and we need you out of the labs and in front of the screens to share with us your findings.
Exactly. We don't have so many chances to go out and say what we find, but that's a good chance now.
It's great for us.
Yes.
So, Andreas, you focus on food safety.
Yes.
So food poisoning, basically,
yes, exactly.
how food poisoning works, so on pathogens.
Yes.
And you also have a focus on pasteurization without using heat, but using pressure.
Yes, I have a focus on any method that we use in order to make food safe.
Yeah.
So there are many techniques. The classical one, we have heating. We also have very old techniques like adding salt and sugar.
Yeah.
This is something that people should know, that when we add salt and sugar, most of the times it's not there to make it tastier, but it's there to make it safe. And we have a lot of cases where companies actually try to remove these parameters from there, remove salt and sugar, because obviously it's not very healthy. But they might not think about the fact that these parameters are there to make food safe. So this is something that people need to know as well, that mainly we put sugar and salt there in order to make food safer, because it stops the growth of bacteria. But I'm also looking at more modern techniques. So one of them is high pressure, where we pressurize the food and we kill the microbes. And this is a relatively modern technique. It's
in Brussels.
I think the first products were back in the 1990s. But we have also other techniques, like antimicrobial compounds, which a lot of people call preservatives.
Yeah.
Also some more modern techniques like plasma, ultrasound, that we might see in the future a little bit more applied. So I look at every technique we have in order to make food safe and how we kill the pathogens, spoilage.
Okay, so let's go back to the basics of food safety.
Yes.
So I've looked at stats, and there are around 600 million people a year worldwide that are recorded to have a problem with food poisoning, and around 500,400 people die every year of food poisoning.
Exactly.
And 40% are less than 5 years old.
Yes.
So
That's one of the big problems, that we lose a lot of young people around the world. And I would like to mention something that's quite interesting. All these numbers that you mentioned are the numbers that they are recorded.
Correct. That's where I was going to come to.
Exactly. So if I ask you, when you feel a little bit of a stomach ache, or you have a little bit of some problems with your intestinal, tract, do you go to the hospital?
No.
Exactly. So imagine most of these times there is something that might not make you sick, very sick, but might make somebody else very sick, because that depends on our immune system, on how we respond. So the interesting thing is that when we see some numbers, we normally need to multiply it by many times. I would say we say in an average about 10 times more.
Wow.
So if we want to find the cases, like we have about a little bit above 2 million cases in the UK per year, it's probably more than 20 million, the real cases, because of the fact that you mentioned you never go to the hospital.
It is true. Recently, one of my sons had food poisoning, and I was asked to fill a form and all of that. And actually, I'll put my hand up. I'm a busy mom of two. I work. I thought to myself, you know what? It's done. What's the point in filling this form?
Yes,
so I didn't do it. So it's not recorded.
Yes, exactly. It's not recorded.
Yeah.
So this is our problem. When
Yeah.
we see the numbers, it's very difficult for us to calculate what's the real number, because we have this very big range of responses to the same outbreak, from people that they might not have any symptoms at all, people that they are sick, people that they are very sick, and people that they die.
Yeah.
So it's like an iceberg. We see only the top of the iceberg, but underneath it's a whole mass of big problem, which a lot of times we don't really recognize, because we see just, 3 cases. But it might be 30, it might be 50, right?
So I'd like to, zoom in on a couple of points. The first one is why the majority of people affected are under the age of 5. Why is it such a large number?
As we said, a very important parameter is the immune system that you have. And when we have young people, their immune system, babies, infants, their immune system is not very well developed.
Yeah.
And for that reason, a lot of people that they die around the world are are younger,
Yeah.
Infants, babies, and as well, if you are not fed very well, you are more prone to have these diseases, and the outcome might be worse. A lot of times in places where we have war or any natural disasters, we have also problems with supply of safe food, mainly water a lot of times. Mm-hmm. This is also a very big problem.
Absolutely.
And I mean, even in war cases, we know that most of the people die actually from diseases and not from bullets and bombs.
Yeah,
and that's standard in almost any case. So because of the supply of food that is disrupted even to the soldiers and the general population. So that's...
But since the introduction of refrigeration, so over 100 years ago, surely these numbers have improved, right?
Obviously.
Yeah,
I mean,
okay.
I just want to tell you that...
Because they sound so bad.
Yeah, but I'll tell you, microbiology is not a very old science in a way.
Yes.
That we understand the role of microbes in disease. It was in the end of 1800s that actually microbiology even started. And until the end of 1800, we didn't even know the role of microbes in disease. We hadn't connected it. We thought that these were some things that we could see in the microscope. Some people say, okay, they don't do anything. So it's a little bit more than 120 years that we started to understand what the microbes do to us.
Interesting.
So it's a modern science. I mean, the founder of modern microbiology is Pasteur.
Exact, yeah, that's correct. So that's 19th century, yeah.
Exactly.
So I remember when we met, I spoke to you about this in this instance where my son had food poisoning, but my other son didn't, and yet they had similar food. And you said to me, people don't understand that the problem is not just the food, it's their own system.
Exactly.
So tell us about that, because normally when you go for a meal with friends, and if one of them has food poisoning, but the other one doesn't, eating the same food, we immediately jump to the conclusion that it wasn't that food that caused it. But actually you're saying that food could have been contaminated, but one person has an immune system and a gut bacteria that can deal with it, but the next person has a gut bacteria and an immune system that can't deal with it.
Exactly. First of all, I would like to say a lot of times we we think that the food that caused the problem is the last thing we ate. And this is not really the case, because there is hardly any disease, any foodborne illness that can show symptoms within 3 or 4 hours. So it's normally something that we ate a few days before, 1-2 days before, So, or it can be something that we ate much earlier, so we had the symptoms in the night, but we ate it during, lunch. So that's something that we need to know. But most of the cases is actually something that we ate 1 or 2 days before. So it is possible that you think that the problem is what you ate last, but normally it's not. Because there is not enough time for either the toxin or the microbe to actually go to the intestine and cause this problem. It needs some time. So normally we need about 6 hours at least to have the symptoms. And if it is 6 hours, it's normally a toxin that either has been produced by a bacterium or it has been in the food. But most of the times it's not that. It's a bacterium that causes an effect, and most of the times it takes more than 1 day.
Okay, so I'm going to
So we get very wrong opinion about what has caused the problem, and that's why we end up in false explanations.
Absolutely, and accusations.
Yeah, and obviously the immune system plays a very big role, because we know that some people they eat exactly the same food and they don't react, but some people they do. And we also know it's quite interesting, but back in the 60s, in the previous century, they were doing trials with non-lethal pathogens with prisoners in the US. So we know quite well that there is a very big difference in response between one person and the other.
Oh my God.
I know they are not really.
That's crazy.
We don't really do these experiments nowadays, but we have the data.
So they would go to prison in the US. They would take pathogens that made people sick, but not kill them.
I think there was a process where they would get involved and they would give them a pathogen. And they would say, okay, you'll just have a little bit of a diarrhea or a problem, and they would participate. They were participating.
But
it's unethical, but we have the data, so we know there is a very big difference in response.
Actually, if someone killed and raped, I'm going to say something, I'm going to get cancelled for this, but I'd rather test these things on someone who killed or raped rather than on an innocent dog. So,
I don't think it's a good idea to test these things, but I mean, we have the data, and we can see that there is a big difference in how people respond with exactly the same pathogen. Food and exactly the same material. It's exactly the same, and people respond very differently. Obviously, depending on the age, depending on how old they are, what's their immune system. Probably, if their organism has seen this bacterium before, if you are used to that, you can identify it probably and protect yourself.
So how can you improve your tolerance to these kind of germs so you lesser the chances of a food poisoning?
I would say keep your body healthy. A lot of people that I speak, that they are not scientists, they would say train your body and don't care about what you eat, because the more pathogens you see, the more trained you are. However, I don't think this is a good idea, because the more you are exposed, the more you are risking yourself. We know that many years ago, people were not living as we live. The life expectancy was very, very low. So
I have a friend,
it's not a very good idea to test.
I have a friend of mine whose mom lived close to 100 years old. Vanessa Branson, Richard Branson's sister, and she told me, so she's super strong. Their family, they're all vibrant and very strong. And she told me that when they were little and they traveled, and they would travel a lot, their mother, Eve, would give them a little bit of the local tap water to drink wherever they arrived. Is this a good idea?
I cannot comment on that, to be honest. I mean, if the local water is safe, I wouldn't say I wouldn't have any problem with that. But if it's unsafe,
you get sick, and that's that.
You might get sick. Yeah. Yes. I mean, it's similar with COVID-19.
Yes.
I mean, it's the same. A lot of people were saying, "Oh, I'm young. I don't have any problem." but somehow their immune system it was compromised.
Yes.
Or it was not compromised. It couldn't really cope with the disease.
Yeah.
And sometimes you cannot really predict that, who is going to be resistant and who is going to be sensitive. I mean, with COVID-19, we could see people that they are, 80 years old, very thin, and you would see this person and say, oh, probably this guy is not going to make it, but they wouldn't get sick because their immune system is in a very good condition. But vice versa, you could see somebody who was young but died from COVID-19 because their immune system. There is a general rule where younger people, obviously, they have a better immune system, and as you get older, the immune system is not up to a good level, to respond to these diseases and infections. But there are always exceptions, and there are not few.
True. So basically, like the basic immune system things that we know, which is good gut bacteria, plenty of vitamin D, zinc, all these things quite high in the system to be able to cope with.
Yeah, I mean, having a good health, good exercise, good diet. I would say this is very important. Keep your health, your body healthy.
But when it comes to exercise, there's so much misunderstanding. But obviously, my specialty is chronic inflammation because I suffer from inflammatory issues. And I know that intense exercise can actually compromise the immune system. And that's happened to me. And I've seen people during COVID-19, people who used to really push in terms of exercise, and it hit them bad.
I mean, I'm not an expert. I'm a microbiologist, but I know very well that when we want to calm the immune system of somebody, we give steroids.
Yeah.
And we know as well that people that they get big muscle mass, they are also taking steroids. So an appearance, a lot of times that somebody, is healthy, it doesn't mean a lot, I would say, in terms of the immune system.
True.
It's genetic. It's genetics, and we can never see through the genetics. I mean, if you do a DNA test to see where you are coming from, a lot of times, these companies are actually looking at immune system genes.
Yeah.
Because these are very, very variable.
Correct.
And because they are very variable, they use them to identify where you are coming from.
Mm-hmm.
And because they are variable, it means also that we are not going to have all of us the same response. And that's the whole idea.
Yeah, absolutely.
Right?
In your day-to-day work, what are you trying to improve? The research that you're doing is to understand better how these different germs function to be able to then help food companies or doctors or hospitals deal with cases of food poisoning?
Yes. So we study all the environmental, we call them environmental conditions, which practically a lot of stresses that we apply to these bacteria or the bacteria find themselves.
Yeah.
And we try to understand how these bacteria survive these stresses. And by knowing the mechanisms, we can target afterwards and make them more sensitive. We can target them and make them more sensitive so we can kill them much more easy. And also, these processes that we use are more efficient, right? So, for example, a work that we do in our lab, you mentioned about high pressure before. Mm-hmm. So, high pressure is a relatively modern technique. So, we really don't know exactly how the microorganisms survive this high pressure and how they resist. And a lot of times we might get a different response. Although we expect that they will be more sensitive, they might be a little bit more resistant. So what we are doing in our lab, we are using Escherichia coli, which is a very well-known bacterium. Yeah. And we have all the genes, we have a library where all the genes are deleted, each one separately. Yeah. And then we put them under high pressure, and we see which one of the mutants is more sensitive or more resistant. So if one mutant that misses that specific gene is more sensitive, then we know that this gene is actually very important for the microbe to make it resistant. Yes. So once we finish all this work, I mean, we have been through probably 1/3 of the genome of E. coli. Once we finish all this work and we complete all the genome, then we will know all the genes that they are playing a role under high pressure. Now, you can actually look at the literature and find how you can manipulate this gene.
Oh, really?
Yes, because we have all the literature. So, for example, if you have a gene that is being downregulated, let's say one gene is very important for high pressure resistance.
Yeah.
Or for any acid resistance or antimicrobial resistance. So once we have this target and we know that this plays a role, we can look in the literature and find out that this gene, for example, is downregulated under a specific condition, like when a specific nutrient is present in the food.
I see. So you add that
or
to
a chemical, exactly. And then you can manipulate this resistance and make
bring
it very
down.
sensitive.
Amazing.
And then you can use high pressure in order to
make it work
better. A typical example of what we do as well in the lab, we have, I don't know if you are aware of niacin.
No.
Niacin is a food grade antimicrobial that's being produced by Lactococcus lactis,
Okay.
lactic acid bacteria. So that compound is actually antimicrobial. And you can find it in a lot of fermented products because lactic acid bacteria that they do this job, they produce it naturally. Niacin.
N-I-C-I-N.
N-I-S-A-I-N. Niacin.
Okay.
Niacin. Right? So we can actually add this compound, and we have found when we add this compound, it works together with high pressure, and we can kill much more easy. And in experiments in the lab, we managed to inactivate the microbes in half the time. The investment for high pressure is very, very high. These machines cost sometimes millions.
Yeah, I remember.
So practically, the company might be able to produce more product with the same investment.
Amazing.
And make the products cheaper and safer, or safer if they can keep the same treatment but make it safer, right?
So that's interesting. So just to summarize, let's say you have E. coli. You analyze the genome of E. coli.
We know the genome.
Yeah.
And it's a university in Japan, and sometimes we do it ourselves with Listeria, with other organisms. We have the ability to remove a gene, to delete it from the genome.
Wow.
We cannot do these experiments with humans.
Wow.
It's illegal. It's unethical. And we use another way to do this with humans. We try to find people that they miss this gene naturally, right? And then we can understand what this gene does. I was reading lately that there was somebody who doesn't feel pain.
Yeah.
Like I remember he got burned. He got burned because he burned himself because he sat on
oh my God.
On a heater.
That's actually
so dangerous. And he didn't feel any pain at all.
That's so dangerous.
Right? And it's dangerous, exactly.
Yeah.
So then they analyzed one or two of these people and they found that there is a specific gene that's responsible for pain. Right? So that's the way that we find out with humans. We need to find somebody who naturally has this deletion. However, with bacteria, there are no ethical restrictions. And with genetic techniques, we can remove any gene we like. So for E. coli, which is probably the most studied organism that more than humans, I would say, we have a library where we have deleted all the genes one by one. So we have one bacterium that is missing one gene. Another one, E. coli as well, exactly the same as the previous one, is missing another one. Okay, and we have them in the freezer. And we can either take them all and screen something, as we do with high pressure, or other techniques, and try to understand at the molecular level which genes are playing a role for each one of the techniques we use for food. And then we can look afterwards at the genes that they are playing a role and how we can manipulate them with environmental conditions. Like I told you with niacin, for example, we can combine and we can make food more safe. Amazing. Or cheaper or healthier.
Yeah.
Yeah.
So obviously this is fantastic for the food industry. So do they finance the studies or do they part finance?
Normally, because these are really fundamental studies, we are getting money from funding agents.
Yeah.
And we don't really
I mean, it's for the general public.
Yeah,
obviously.
it's for the general public. However, we have applications where we find how we can manipulate the gene, and then we collaborate with the company.
Yeah.
So we have collaborated, for example, with a company that makes disinfectants.
Yeah.
Like every apple or every fruit or every vegetable you get from the supermarket has been through a washing step.
Yeah.
With water and a disinfectant.
Yeah.
And then water again, right?
Yeah.
So, and normally, a lot of times, especially with fruits, disinfectants are a little bit acidic. They have some acid.
Okay.
And we have studied quite a lot the main mechanism some pathogens use to survive acid, which is amino acid decarboxylase systems. I don't want to make it very complicated, but let's say, yeah, we have found that these genes are very important. And we know that when we add some inhibitors of these systems, the microorganism cannot use it and becomes very sensitive to acid.
Interesting.
So then you can either make a choice as a company to either disinfect maybe at higher pH, so you don't damage your fruit so much, or for a shorter time, or you can keep the same, but you are sure that you have eliminated much more. So it's a much more sophisticated way, because the normal way is actually, okay, I want to make the process more safe. I will add more acids. I will lower the pH. I will kill more. But we use a more sophisticated way and more delicate way to have the same effect. We try to make the microbes not being able to resist to the stress that we are giving them.
And are you able to preserve the good guys? So obviously all these techniques are fantastic to reduce the chances of foodborne illness, but we're also probably destroying some prebiotics and some good bacteria for the gut.
No, I mean, let's say you don't rely so much to get your good bacteria from a fruit. Although I would say the lactic acid bacteria are probably a little bit more resistant to acid, so they wouldn't die so easily. But we haven't tried to see that. So let's say if you get your fresh food that has been, let's say, processed through an antimicrobial, which is normal, and then, you don't really rely on your lettuce or your apple to get your lactic acid bacteria. Normally, you would get them from a fermented food, like a yogurt or something like that. Yeah, there we don't really do that. We do the opposite, though, because we know how the system works. We can do the opposite with lactic acid bacteria. We can add something in order to enhance the acid resistance, because we want the lactic acid bacteria to survive.
I see.
So when you have this targeted approach, you can do whatever you want. Either you can inhibit the bacteria that you don't want, or you can boost the bacteria that you want. So if you are in a food fermentation, you want the lactic acid bacteria to survive. So you might add a compound which enhances their acid survival.
Yeah, so you make it more...
You make it more easy for them.
Yeah.
And something very interesting is that I have been working more than 15 years on a specific system which is called glutamate decarboxylase. Sounds very scientific, but wait a little bit and you see where I'm going with it. This system, when the bacteria use it, they survive acid. However, and they consume glutamate and they produce GABA.
Oh, interesting.
So the bacteria...
Oh my God, the bacteria produces GABA?
Yeah, so now it's very interesting because we have the glutamate and the GABA, which are the two main chemicals we use in our brain.
Absolutely.
The bacteria use it in order to survive acids. So they convert glutamate into GABA and they survive more.
Fantastic.
So now we can actually produce foods that they produce more GABA from lactic acid bacteria by making them more acid resistant. So you get lactic acid bacteria that are more acid resistant. You can get more GABA in the food, which is, as we know, GABA is beneficial because it lowers the blood pressure, which is a very big problem nowadays.
Yeah.
And also, we are looking at it as a candidate for the gut-brain axis.
Absolutely.
So we can use fermented foods in that way. And by knowing the molecular mechanisms, we can manipulate them and get what we want from the bacteria. And there are a lot of GABA-enriched foods nowadays in Asia, around the world which take advantage of what I'm...
Is this what they're doing? Okay.
Exactly.
But my question was, and I know it's a really basic question, but so I know that obviously kefir will have much more probiotics than an apple, but in all the fiber of the apple, there's prebiotics for the probiotics in the gut.
Of course.
But if you're ingesting, so the water has been washed with a bit of an acidic solution to kill the bacteria and make it safe. When you're consuming it, let's say without peeling it, and also the majority of the nutrients in the apple are in the skin, so you want to eat the skin, will that wipe out a little bit of your internal bacteria?
No, because the amounts that, first of all, most of the companies, they don't use any acids that they are very strong.
Okay.
And they use normally acids that they exist in food.
Okay.
So they don't really use some very exotic.
Yeah, it's already there.
Yeah, it's already there.
Yeah.
So we use combinations of acids that they are already there.
Yeah.
So you don't really add something toxic or something
so you're
dangerous,
staying,
right?
Yeah, in that homeostasis.
Yes, and then afterwards, after this process, which is normal, we wash with water. They wash with water. The companies would do with a lot of water. So even that tiny amount will be completely gone.
Okay.
There will be nothing there. So in terms of amounts that you get something that you would get with food more or less anyway, and in a much lower concentration. So it's not really
fantastic.
A big problem, let's say.
It's so great to hear all these different methods of pasteurization because, if you're not somebody who knows about it, you think about pasteurization, you boil the milk, and you're killing the lactase.
Exactly.
But actually, if you're doing the high pressure, you're preserving the lactase and you're preserving nutrients.
Exactly. So the whole idea nowadays is that we are going away from the classical techniques of I'll heat up everything.
Yeah.
So somehow in the modern world, and probably as we go forward, we have different techniques for different groups of foods. So I think I told you before that about half of the juices, 50% of the juices we consume in the UK are actually produced by high pressure.
Yes.
And that has contributed dramatically in the improvement of the quality of the juices. Yeah. Because when I was young, the juices from the supermarket were not this quality, right? So now the juices that we consume, we buy from the supermarket are much better. And that is because of this technique. And the first product that was launched with high pressure in the market was guacamole.
Oh my God, yes. I always wondered, how does it stay? It doesn't oxidate.
Exactly.
But you cut an avocado at home, it goes brown.
Exactly. So guacamole, if you make it at home, there is no way, you make it, you eat, and that's it. The rest is thrown away. In addition to that, if you want to preserve it, it doesn't have any safety factor, as we call it in food safety. So it doesn't have any natural acids or natural antimicrobials that can protect the product. So if you keep it, it's very prone to bad bacteria growing there and causing you a food problem, food poisoning.
Yeah.
The reason why we have guacamole in the supermarket is high pressure.
Amazing.
Because if you heat it up, it's going to get brown.
In 2 seconds.
In 2 seconds. So there is no way you can heat up guacamole. It's impossible. So normally we pasteurize it with high pressure, and you can transport it to the supermarket, and you can keep it at home.
Is that what they do for pre-cut fruit as well? You know how
sometimes
the apple
you might do. Sometimes I think a lot of times you might add a little bit of citric acid or lemon, to lower the pH so it doesn't get. But guacamole is high pressure. You need to use high pressure, and this was the first product ever with high pressure. Although it's quite interesting, the technique was discovered in 1890.
No way.
Yes.
It took so long.
Yeah, because it was much cheaper to heat up things.
Of course.
With pasteurizing with heat,
Yeah, cost.
And at that time, the technology was actually not very good in order to make metals very resistant to pressure.
I see.
But the original discovery was 1890. And it was forgotten completely. Until the 90s, almost 100 years later, they said, somebody found the original paper and said, we can use that because now we have the engineering, we have the technology to make more resistant metal vessels which can withstand all this pressure.
But you know what's interesting is if you don't try, you don't find out.
Of course.
So I'm completely off topic. As you're talking, I'm thinking, I'm working on a range of probiotics, okay? And I do not want to use some excipients which are linked to problems in the gut. And even though it's a tiny amount, I want to have a really clean line. And actually, I have found a way of doing it using prebiotic as an excipient. So it improves the product, but no one else is doing it. Why? Because no one tried.
Yeah, you need to.
Sometimes it's there in front of you. The better option is there, but you just haven't tried.
Yeah, we always need to try. And that's what I'm saying now. We are studying all these novel techniques, plasma, ultrasound, high pressure. So these are novel techniques that they don't use heat.
Yeah.
So we hope that they will find applications in the food industry to more and more.
Preserve nutrients and make the food safe.
Exactly. And this is also what I'm doing. I'm studying oxidative stress. So this is another stress that we use. And by looking at the genes, we can find out again how we can make cells more sensitive, bacteria more sensitive. And these techniques can find more applications in the food industry.
Amazing.
Make food more safe.
Thank you for listening so far. We'll be continuing this conversation in part 2, so make sure you're subscribed to the Eat, Burn, Sleep podcast so you do not miss it. In the meantime, for those of you who are not members of the platform yet, we have a discount code for all our podcast listeners. You can get 15% off all Eat, Burn, Sleep memberships. Just enter the code podcast15 at checkout on the memberships page on eatburnsleep.com. We still have so much more to cover, so please stay tuned.